All right, we're going to do the second configuration. We're going to create basically a parallel plate. Let's start placing these charges, and it's going to simulate the charge on a parallel plate. I'll just use maybe 6 of these charges. All right, now let's do some on this side. And I'm using the grid to help me make it a little pretty symmetric. This is kind of simulates a parallel plate capacitor. You can see that these lines here in the center are pretty much straight, especially right in the center. They're pretty much straight. You get some edge effects up here where they're bowed out a little bit. And if we were to take our sensor, you could see that it's the force is real strong as it gets closer to here. So you would need to put energy to put a positive charge towards that plate. And here it's attracted, the positive charge is attracted to this side of the plate. Okay, let's get rid of that. And let's measure, just pick a point here. I don't know if it's, this one's 600. I don't know if you can see that. It's 600 centimeters, so that's 6 meters. So let's retire that. Oh, I should probably take a shot of that. Let me do that. That's close enough. All right, let's return that, and let's start doing our measurements. And let's try to do it in the center there. And we'll display these. Values afterwards. What this is drawing again is the equipotential lines. There's one that's right about 0. So this one really should go up and down almost to infinity if you want. It's the 0 potential where you would measure 0 volts or close to 0 volts along that line. And I think that's it. And let's show the values. Let's take away the grid. I think it'll actually for this I may have to. I'll shoot it both with the vectors on, and let's take them off so that it'll be easier to see. And there you go. Those are your equipotential lines for the parallel plate, and that should we'll end that.